The work function for cesium atom is 1.9 electron volts. Threshold wavelength is expected, and what else is expected? Threshold frequency. Well, I guess that's not a magical thing. We can do that very easily. How? Work function is nothing but energy. So W naught is H nu naught, which is Hc by lambda naught. You can do whatever you like. I think I'll start with frequency. Threshold frequency is 1.9 electron volt. 1 electron volt is so many joules. Divided by H, 6.626 into 10 to the minus 34 joules second. God save us. What do we have? 1.9 into 1.6 by 6.626. 34 minus 19 is 15. Well, per second, which is so many hertz into 10 raised to 14. That would come out to be the order of magnitude. And this would be 16 fours are 64. That is about 4 point something it would be. 4.9, 4.8, something in that range. What is that here? 4.593. Let me write it down for you. 4.593 into 10 raised to 14 hertz. This is threshold frequency, right? What about threshold wavelength? Nu naught is C by lambda naught. Therefore, lambda naught will be 3 into 10 raised to 8 meters per second by divided by threshold frequency 4.593 into 10 raised to 14 per second. If I just approximate 3 and 4.5, that is 1 by 1.5, which is 0.67, 0.62 around 6 something into 10 raised to minus 6 meter or 6 point something something, 653 nanometers, 6.53. So let me come back. 0.653 if it is 653 nanometer. This is threshold wavelength for you. And then it says if cesium element is irradiated with a wavelength of 500 nanometers, calculate the kinetic energy and the velocity of ejected photoelectrons. More work. How do we do this? E kinetic. Yeah, Ke max is work function minus, energy of incident radiation minus work function. So, what is the energy of incident radiation? Let's find out. It is Hc by lambda minus Hc by lambda naught, something along those lines, right? 500 nanometers. Hc 1 upon 500 minus 1 upon 653 into 10 is to 9 per meter. Nano from up 10 is to minus 9, when it comes up it becomes 10 is to plus 9. What do I need to do? I just substitute and calculate and just have fun. Atomic structure is a very calculation intensive chapter. It would be very useful if you learn some quick random calculations. So this is accurately 6.626 into 3 into 10 is to minus 34 plus 8. 34 plus 8 makes it minus 26 joules second, joules into meter, yeah. And per meter will cancel away with that, into 10 is to 9 per meter, of course, goes off. This is 153 by 500 into 653. Loving calculation, I must say. How very emotional. This makes it, well, 26 3s are 78, 6 3s are 18, 19.88 into this ugly number. 153 4s would be 612. And this is 653 around 41 more than that, 41. Now, this is 0.3 times roughly. So this would be how much? 4.3 around, roughly. By around 4.3. And of course, that 500 is very much there. 10 is to minus 26. I take off this. That makes it minus 29 plus 9, 10 is to minus 20. How much is this? This is joules. Such a wondrous change. Let me say this is around 20. No, 40. 40 by 4.3. A little less than 40 divided by 4.3. That would be around 9. Roughly 9 into 10 is to minus 20 joules. Roughly. This looks like the kinetic energy of photoelectrons. Let's check the number. 9.3 into 10 to the minus 20. After a lot of jumps, we are reasonably close. 9.3. Well, I like that. What I'm trying to do is, don't use calculator always. At least try to do rough calculations so that you know that you're getting close to this answer. Many times in exams, it's a very useful technique. Lastly, we have to find the velocity of ejected photoelectron. Wow, how do we find that? Very easy. Half mv square is Ke max. So V is under root kinetic energy into 2 by m. Right? We know the kinetic energy, 9.3 into 10 minus 20 joules into 2 by mass of electron is 9.1 into 10 minus 31 kg. Substitute, calculate and get the answer. Let's do that. Major part is calculation and being able to do this correctly. That was 9.3 into 10 to minus 20 joules divided by mass, which is 9.1 into 10 to minus 31 kilograms. Fanciful. This is a little more than 1 into 2, whatever that comes out to be. And there is more ugliness. 10 is to 11. So this is going to be around 22 point something into 10 into 10 is to 10. Around 21, 22 roughly, that's the number. Right? A little more than this is 2 point something into 10. Now please note 9.3 by 9.1 will be 1.0 something. That square root will be still smaller. So I assume that, say this is roughly around 2.05. If this is the case, I would have around 20.5 into 10 is to minus 10, plus 10, sorry. You leave it out. Root of 20.5, 16's root is 4. What about 4.5? 4.5 square root is 20.5, yes, roughly, yeah. So 4.5 into 10 is to 5 meters per second. We are very close, 4.5 to good enough, good enough. This is what we get.